LDL cholesterol level under 100 milligrams per deciliter is often described as desirable. But did you know that LDL and LDL cholesterol are two very different things? That cholesterol itself is not the main problem, that HDL is not good cholesterol, and even LDL is not bad per se. What? Fat and water don't mix. So our body found a solution to transport fats in our bloodstream: lipoproteins. Lipo means fat. So a lipoprotein is basically a ball of fat and protein. You know at least two of them: low density lipoprotein, or LDL, and high density lipoprotein, or HDL. Okay, how exactly does this nerd fest help me with my health? Your lab results usually don't show LDL. They show LDL cholesterol level. So what's that? Lipoproteins like LDL carry different types of fat. Cholesterol is one type. So LDL cholesterol is the cholesterol carried in LDL lipoproteins. Imagine each LDL lipoprotein is like a car driving down the road. LDL cholesterol are the passengers in those cars. And HDL cholesterol, which you also have in your lab results, is of course the cholesterol traveling in the HDL lipoproteins. Bonus question: what do you get if you add up all the cholesterol, all the passengers in all the cars in your bloodstream? Total cholesterol, which you also have in your lab results. The other thing on your labs are triglycerides, which is another type of fat that also travels in lipoproteins in our bloodstream. So they're another type of passenger. Okay, so now you know the difference between LDL and LDL cholesterol. One is the vehicle, the other is the passenger. Why does any of this matter? We'll find out in a second. What about the story of good cholesterol and bad cholesterol? Where does that come from? Let's start with LDL cholesterol. Why do people say it's bad? We know that lab animals with high LDL cholesterol level can form artery plaque. Okay, but mice also like to run in wheels. How do we know this has anything to do with humans? Population studies show that people with high LDL cholesterol level also tend to have more heart disease. Interesting, but if you saw the previous videos on olive oil and saturated fat, you know that these population studies can be a little tricky. Maybe people with low LDL cholesterol level are health freaks and they exercise more and smoke less and have kale smoothies and meditate all day long. So we want to avoid jumping to conclusions just based on population studies. By now you probably know the drill. We need to randomize people to different groups, lower LDL cholesterol level in only one, and see what happens. This has been done many times using different drugs, including statins and many others, and in study after study, the group that gets the drug and has its LDL cholesterol level lowered has less heart disease. If instead of drugs you use diet, you get a similar result, as we saw in the saturated fat video. Okay, so high LDL cholesterol level is a problem in lab animals and in population studies, and if you lower it experimentally, you lower the risk. This makes a very strong case that high LDL cholesterol level is an issue. But there's even more evidence. We all have different genetics. That's why we're all a little different. Some are taller, some have wavy hair, some have big noses. Hey! Our genetic differences also mean that we have different levels of LDL cholesterol among each other. So scientists studied people who have low LDL cholesterol level from birth, and they have much less heart disease than the average population, up to 10 times less in some cases. This does not mean that your LDL cholesterol level is 100% determined by your genes and there's nothing you can do, period. That's a common belief and it's not factual at all. Genes play a role, just like in everything else, but there's a lot we can do with lifestyle. For example, we just saw that the saturated fat we eat is a major player. We'll come back to this. All this evidence accumulated over decades is why scientists are very confident that high LDL cholesterol level spells trouble. Check out the wording in this study. There is no longer an LDL cholesterol hypothesis, but established facts that increased LDL cholesterol level is causally related to atherosclerotic cardiovascular disease, that's plaque in the arteries, and that lowering LDL particles and other ApoB-containing lipoproteins, we'll see what that means in a minute, as much as possible reduces cardiovascular events. So that's very striking language, because scientists are usually tentative in how they phrase their findings. When we publish papers, we write things like, the data indicates, or this suggests that, but here the wording couldn't be any stronger. So who are these authors? Is it some fringe vegan scientist? No, These are the official guidelines from the European Society of Cardiology, and it's the same thing all over the world. Here's the American Heart Association. Established a causal role of cholesterol-containing lipoproteins, particularly LDL, in the genesis of coronary heart disease. So now we understand the why. What evidence led to these conclusions? It's not some doctrine down from above. Okay, so high LDL cholesterol level causes heart disease, right? I think I got it. Not quite. Plot twist. See, LDL cholesterol is not the main problem. The main problem are the lipoproteins themselves, the vehicles. As these authors explain, their work suggests that it is the number of lipoprotein particles, rather than the amount of cholesterol or triglycerides per se, that is the important driver of heart disease. Heart disease is caused by lipoproteins getting stuck in the artery wall and potentially causing a blockage. So what causes a traffic jam is an excess of cars, not passengers. So can we count cars? Because normally our lab results only show passengers. LDL cholesterol, triglycerides. Yes, we can. We can measure something called ApoB, which is one of the proteins carried by LDL. So if we count how many ApoB proteins there are, we know the number of lipoproteins that carry it. Another test is called LDLP, where P stands for particle, and it's literally a count of the number of LDL lipoproteins. So both of these are a measure of cars, not passengers, and they're not done routinely by primary care physicians, but if you're seeing a cardiologist, for example, and if he or she thinks it makes sense, they might request it. Okay, so if the number of LDL lipoproteins, the vehicles, is the main cause of heart disease, but normally our lab results only show passengers, the cholesterol, then what's the point? Is LDL cholesterol level useless? For most people, these metrics go hand in hand. More lipoproteins in our blood normally means more cholesterol being carried inside them. In a percentage of people, around 20% give or take depending on the study, there can be a disconnect. And that's worth bearing in mind. But for the majority of us, LDL cholesterol level is a decent estimation, and it's still considered an important parameter even by cardiologists. Another metric is non-HDL cholesterol, which is just the total minus HDL cholesterol. So it's all the cholesterol not carried by HDL lipoproteins. And it's also commonly used by doctors. I swear to God, if this guy shows one more acronym, I'm going back to cat videos. I know this is a lot of different terms, so we'll do a quick review in a second. So if your LDL cholesterol level is good, chances are your LDL particle number is also okay. But if you have concerns and you want to make sure, maybe if you have family history, see your doctor and consider seeing a cardiologist. And I'll try to have one on here soon so we can ask additional questions you guys may have. Okay, I think I got it. So lipoproteins carry cholesterol and other fats. Lipoproteins can cause heart disease if there are too many of them, especially LDL. And LDL cholesterol is just the passenger, but it gives us an idea of the number of LDL lipoproteins. All right. And HDL is good, right? Actually, plot twist. This guy's worse than Dan Brown. In the population studies, people with high HDL cholesterol tend to have less heart disease. That's why people started calling it good cholesterol. But when scientists tried to confirm it, raising HDL cholesterol with drugs didn't help at all. Their risk did not improve. And people who have genetically high HDL cholesterol aren't better off either. So this was a huge surprise, but it's actually very consistent. This study concludes, although observational studies, that's the population studies we looked at, might suggest a simplistic hypothesis for HDL cholesterol, namely that increasing its level reduces cardiovascular events, substantial trials do not support this concept. And they pooled 39 trials for this analysis, done with 3 different drugs. So it pretty much looks like a dead horse. Now, that doesn't mean HDL is useless. Not at all. We know the HDL lipoproteins, the vehicles, play many physiological roles, like for example, pulling cholesterol from plaque. But this simplistic idea of trying to raise HDL cholesterol, I hear people all the time, how do I get my HDL higher? And they say HDL, but they really mean HDL cholesterol, the value we see in our lab results, right? And now you know the difference. Trying to raise our HDL cholesterol, there's no evidence that it helps at all. In fact, this gets even worse. Some studies suggest that a very high HDL cholesterol level is associated with higher cardiovascular risk. So this idea that having high LDL cholesterol is fine as long as your HDL cholesterol is also high, looking at all the evidence, there's no reason to believe that idea. So are you saying HDL cholesterol is bad? No. I'm saying we should avoid thinking in those terms altogether. This almost cartoonish idea of the good and bad cholesterol doesn't match the evidence. But simplicity sticks, so a lot of people still think this way. In fact, LDL isn't bad either. We all have LDL, we all have LDL cholesterol, as we should. It's only when it gets off the charts that it becomes a problem. Some people have high glucose or high potassium, and we don't say potassium is bad. If you look at your lab results, almost every parameter has a range. Above a certain level, it starts to get too high and it can lead to physiological problems. LDL cholesterol is no different.